Hello students, in this class we'll see the applications of trigonometry. 10th standard topic applications of trigonometry. We have seen couple of ratios, many ratios, in fact 6 ratios in trigonometry, that is sine ratio, cos, tan and their reciprocal, cosecant, secant and cot. These are angles. So you may ask us question, by studying this sine, where do we, what do we do in life? Where do we apply these things? To that point straight away, remember, none of the mathematics topics straightway gets applied in the life except addition, subtraction, multiplication kind of thing. We cannot apply a plus b whole square. We cannot apply a plus b whole cube. We cannot apply kind of say root numbers, root 3, root 5. Where do we apply? We don't apply. We cannot apply. But as a syllabus, we should study first thing. Second is, it is knowledge that we gain from the topic. Every knowledge need not to be applied in life. Okay, keeping that in mind, yes, we can apply this sine, cos, tan. Straightway we cannot apply, but height, where do we apply this? To find height of objects. Height of objects, say height of a tower, height of a house, we can find by using the trigonometric ratios. Or distance between objects. Distance between objects can be found by trigonometric ratios. That's what we will be seeing in this chapter, applications of trigonometry. Before that, we need some terminologies to understand. The first thing is line of sight. What do you mean by line of sight? Line of sight is nothing but the eye contact with the object. Means there is an eye here, there is an eye of a person. When this person sees an object here, this becomes line of sight. Okay, line of sight. It need not be horizontal to the earth, or it need not be, it can be like not he can see the object which is above his eye level. He can also see object below his eye level, depends. But the line which meets the object and his eye, that line contact is called line of sight. Example, if you see, this is a horizontal line, means this is a earth surface plane. Okay, when the object is above his eye level, see, person is standing here. When he sees an object which is at A now, this line is called line of sight. That line is called line of sight. Remember, it is nothing but a line between the eyesight and the object. Okay. Then, when he sees an object, there are only two types. Whether he can see object above his eye level, so he can see like this, right? He'll make the view upwards, or he may see object below his eye level, that is like this, downwards, right? So the horizontal line is nothing but always eye to the line parallel to the plane, that is earth, that is horizontal plane, horizontal line. When the object is above his eye level, it creates one angle called angle of elevation. When the object is below the line of sight, that is, it creates a angle of depression. Okay, let's see. This is angle of elevation. What do you mean by angle of elevation? Means, see, there is an observer eye here, object here, x, o, y. Then this is a horizontal plane. Okay, when the object is above the eye level, observer's eye level, it creates an angle called angle of elevation. This is angle of elevation. Therefore, YOX is angle of elevation. Understood? It is the angle which is created by the line of sight with the horizontal line when it is above the horizontal line. This is a line of sight above the horizontal line. Okay, this is called angle of elevation. In other words, you see angle of depression. When observer is here, observer's eyes is here, and horizontal line, that is x, I'll say, and y is an object. When he sees below the horizontal line, because the object is lying below the horizontal line, means his line of sight will be downwards. Then that angle formed by the line of sight and the horizontal line is called angle of depression. What is angle of depression here? XOY is angle of depression. Okay. So together if you check, angle of elevation or angle of depression, both are always acute angle. Since they are acute angle, trigonometric ratios can be applied here. Okay. Let's see together when we merge both the concepts. See, there is an observer here as marked here. There is a another observer above the tower. This person, which is who is on the ground, sees a person above the tower. This is angle of line of sight. Line of sight. It creates. Sorry, this is horizontal line, and this is line of sight. Okay, line of sight is means the line where the observer's eye and the object gets contact. So this creates an angle of elevation. Horizontal line is nothing but it's a plane. It's a line parallel to the horizontal plane. Horizontal line is nothing but a line parallel to the horizontal plane, that is the earth. The angle of depression means the person who is above the tower, his angle of line of sight is actually horizontal line is the eye level line is a horizontal line. Okay, this is horizontal line, and he is seeing a person who is on the ground, so his line of sight gets downwards to the with respect to the horizontal line which is for him. This is horizontal line of this person. For this lady, the horizontal line is this. Okay, so when the person above the tower sees a person below the on the ground, so that creates angle of depression here, theta, and I'll say x. So theta is angle of depression here, and x is angle of elevation. You know, elevator means which takes you up, right? Lifts, elevator, escalator. It comes down also. Forget that. So angle of elevation and angle of depression are always acute angles. Acute angles. Remember, angle of depression and angle of elevation in this case they are equal. Because why? Can anyone tell? Because this horizontal line for this person on the tower and this horizontal line on the person on the ground, they are parallel. When they are parallel, angle of depression and angle of elevation are alternate angles, right? These are because they are alternate angles. With this knowledge, we can find distance between the objects, the height of the tower. Example, you can see there is a person, there is a tower here, there is a pole here, and the heights and all some parameters they will give. This is the distance between the height and the pole. Tower person is watching something on the pole. What is the distance between this? So we have to construct a horizontal plane. Some parameters will be given, and we need to find AC here. How do you find? This is the angle. This this tower length will be given, or pole length will be given. Whatever it is, some this will be equal. So some parameters we'll use, and we'll use these trigonometric ratios to calculate the required part. This is the application of trigonometric ratios. Okay, minimal application problems we have. Remember, there is always 4 marks question which is last in question paper asked in the from this chapter. This is a application problem. Please understand, very simple concept. These three things, line of sight, angle of elevation, angle of depression, should be known for that. Okay. Thank you.